Hi, good morning, everyone, whosoever has joined. So, we would be soon starting our session.
Yeah, hi folks. Very good morning today. We are excited to have you back. Hey, hi everyone. Very good morning. Thank you for joining us this Sunday morning. Can anyone confirm if I'm audible correctly, Sunanda?
Yeah, we are able to hear you
Yeah,
loud
great.
and clear.
Oh, that's great. Okay, so we have a couple of folks already in the chat. Biswajit, Dev Explore, Shubham. Hello guys, welcome to today's session. That's great. Thank you, Shubham, for the confirmation. I will just give me a while. I will just clear up my dashboards. Cool. We have our session here. We have everything here. Yes, and that's a go. Hey, hi Avinash. Hi Suryam Dhab. Suryam, if I'm I guess spelling wrong. Hi Niharika.
So, it's so good to see all of you on a Sunday morning. Thank you so much for joining in today. So, I extend a warm welcome to all of you to our Build with AI session. And here we are today. I am Sunanda, and this is Swayam, my co host for the day. So, like, we have a couple of newbies, we have members from our past live sessions also. So, for everyone and anyone who's new, so Build with AI is a series of events dedicated to exploring the fascinating world of AI, as you all know. So, basically, our goal is to bring together enthusiasts, developers, and professionals to learn, share, and build with cutting edge AI technologies. So, we are thrilled here to have all of you today here to continue our journey of discovery. So, before we dive in, again, I just want to take a quick moment to say hello to everyone who has joined in and thank you for being here. We know you guys have a busy schedule and it's obviously a Sunday morning, but we truly appreciate you spending your time with us to learn and connect. So, let's make this as an interactive and insightful session together.
Thank you, Sunanda, for that beautiful introduction. Hi, people. Lovely to see you, everyone, here on Sunday morning. Really glad. So, for our returning members, you can recall the series that we have been going through for a few weeks. People who are new to today's session or haven't been following TFUG Bhubaneswar, You can check out our YouTube channel. You will have the recordings of our previous sessions. For our returning members, I will just like recall our previous session. Our first session in this series involved with Mr. Lalit, who we discussed over leveraging AI to enable data-driven discussion. We also showed a chatbot where Mr. Lalit was interacting on something based on RAG on financial discussions over Indian market. Followed that, we had an interesting session with Himanshu from Servam. He basically showed how we can use AI to leverage the language capabilities of LLMs and break the barriers, especially in a country like India where we have more than around 50 to 60 regional languages. Our last session by Mr. Avinash, we saw a very fascinating framework where he introduced an interesting approach of building LLMs specific for our Indic languages and cultures. We continue to have these fantastic discussions and learn every time we learn something new. Following last session, today we are again back with a session. We would have amazing discussion today. All our recordings of today's session or the previous session would be available on the YouTube page. Feel free to watch our previous videos and drop any questions that you want.
For all the people that those who are not connected with us on socials, you are heartily requested to join us on social so that you get an updates of our next sessions and what we are up to. So you will get an update of everything and anything we do. So moving ahead. We are to be diving into the foundations of large language models, and we are at the heart of the current AI revolution, as you guys know. And understanding the core principles is the key to harness the effective power of you how to use all those AI languages and everything. So today we have the perfect guide for this exploration. So please join me in welcoming Soumendra Kumar Sahu. It's my pleasure to introduce Soumendra Kumar Sahoo, who's a distinguished AI architect at PepsiCo with expertise in AI observability and ML operations. And he holds a strong academic foundation in data science and engineering. He holds a master's degree from BITS Pilani and a bachelor's in electrical engineering from the SOA University. Over the past years, he has been successfully leading teams in developing advanced AI solutions, contributing to the scaling of AI platforms at Freshworks, refining large language models for specialized applications, and spearheading AI operations initiatives at the IBM. So, his dedication to leverage AI for solving real world challenges and driving business growth through data driven insights is truly commendable. So today, Soumendra would look forward to an engaging and insightful discussions, fostering meaningful connections and exploring opportunities for collaboration. So throughout the session, if you guys have any questions, you need any clarification, any of the topics he's going to deliver, please drop your questions in the chat, and we would get back to you at the end of the session. So, Soumendra will take us on a journey through the core concepts of RAG, that is Retrieval Augmented Generation. With him, we will be exploring topics like what exactly RAG is and the significance in the AI system, the key components of RAG, how retrieval and generation, how they work together, and also he will be giving us some insight on practical applications and benefits of RAG. So get ready for a session packed with knowledge. And now I'll hand it over to Soumendra. Soumendra, welcome and over to you.
Yeah. Hi, everyone. Thank you for the warm welcome and introduction, Sunanda. Okay. Hope my audio is clear.
Here.
Okay. Yep. So let me share my screen. Screen. Yep. Are you able to see my screen?
Yes, it's visible now.
Okay. Awesome. So today it's a beginner friendly course. So today we will discuss about retrieval augmented generation. So this is a kind of information retrieval mechanism, and we will first go through the theory part for the first half, And in the second half, we will go through some practical implementation of RAG. In the first half, we will discuss the timeline, like how the RAG got evaluated throughout the years or decades. And then if you have any queries or anything, if I am telling some jargons you are not able to understand, then you can interrupt me and ask the queries directly. I would request the organizers to interrupt me if there are any queries. And yeah, let's start then. Okay, so there are two ways we can approach retrieval augmented generation. So either we can see it from the information retrieval point of view, or we can see it from the LLM's point of view. So let's start with the timeline with information retrieval point of view. Uh, uh, so yeah, so in the 1950s and 60s, uh, how the earlier information retrieval used to happen. So there were not so much of digitalization, and mainly the physical documents were used in libraries, and earlier computer systems were bulky, and um, mainly we used to do metadata based searching, like file creation date, file when is the last file updated, or based on the file name we used to search. We used to maintain a index of the file names, and based on that alphabetically, like if you might have seen any dictionary, so there we can go alphabetically and search any file name, and we can retrieve that to get the information we need. Okay, before that, if the organizers can share this URL in the YouTube chat, so it will be useful for the students to refer this. Yeah. Okay. Anyway, it's rag.soumendrak.com, so you can go through this website. Next, we reached the 70s. So 70s, we went inside the documents. So digitalization starts, the documents get into computers. And there also we have introduced into Boolean operators like and or not. And we have some key developments on TF-IDF mechanism. TF-IDF stands for term frequency, inverse document frequency. In short, it's like if a keyword is found in more the documents, then its value is less. But if the keyword is found in lesser number of documents, then the keyword's value will be more, score will be more, TF-IDF score will be more in those documents. So for example, if there are some common terms like this, where, who, those kind of terms, we generally refer as stop words, or those TF-IDF scores will be less. Or any specific terms like suppose say Indian government or cyclone, something like that. So uh, those will be less appeared in many documents. So those TF-IDF score will be higher. So based on this keyword search and this TF-IDF algo, we used to, in 1970s and 1990s, we used to find the information. At the same time, there are search engines like Alta Vista, which was the predecessor of Google, that got emerged, and with that, the people can able to search not only across their physical realm, other than they can search in the internet um, with seekables and all. Then there was a discovery like Google's PageRank algorithm, and with that, the Google search entered into with that the probabilistic models. So here there is another new algorithm got introduced, BM25, or can be called as best match 25. So in TF-IDF, there were not considering the length of the documents. Like if the document is like say 500 pages, so definitely there will be terms will be appearing more time. So we should not score that higher. In BM25, the length of the document also came into picture. So the algorithm got got better. And uh, 2010s is the era of probabilistic models. So with probability and statistics, we got the documents and informations. Then in 2010s and 2020s, the vector embeddings came into picture. So what are vector embeddings? So every word we represent as a integer or a vector, you can say. So for that, let me show an example. So this is TensorFlow's projector, one project where you can see like in physics or in math, we can show any three-dimensional space using X, Y, and Z axis. So this is a three-dimensional space, and here every node is one word. So this represents like how far is one word it's related to another. So suppose we want to search for queen. Okay, let me refresh. So it will showcase in this three-dimensional plane where is the queen located. So it's located here, and these are the all the other dots you are seeing. So those are the related nodes which are related to the queen, and the distance between queen and these other words are lesser compared to other words here like symptoms and all these things. So similarly, this approach was used like a large text is ingested into a machine learning model, and this vectorization of those words has been prepared. But that we call that as vector embeddings. So there are different kind of embeddings. Popular ones are word to vec. So word to vector. GLOBE stands for global vectorization, and later transformer models got like BERT, um, bidirectional encoding transformer, and those vector representations those got introduced. So with this vector embedding search, we can so to recap a bit. So here we used to search based on the file name and metadata like file creation date and all. Here we used to do keyword search and Boolean search, like search this or that, cyclone or hurricane, like that. And here also we have handled synonyms. So if somebody is searching for king, they can the search for emperor also. They can refer a synonym dictionary, and they can find the search along with king. They can find the synonym emperor. And here we have used probabilistic models with like term frequency, inverse document frequency, and further uh, um, modern models algorithms like BM25 and Google's PageRank algorithm to find out the information. And here we have used vector embeddings. So here not only the keywords, synonyms, we found out the what are the related terms related to those words. So those things we found out using this vector embeddings. And we saw the representation here, how a word can be. So for example, here if someone is searching for queen, so the nearest terms like Queen Victoria, Castle, Windsor, or whatever is nearest terms is there in the document, that document will be given higher score. So this kind of search got improved like that. Then in 2020s, large language models with the invention of transformer. So large language models like GPT, BERT, T5, those got introduced. Here also around same time in 2020, RAG also got introduced at the same time. So RAG initially proposed using sequence to sequence model. Okay, so let's see how now to go into more into details into RAG. Let's go into detail how exactly RAG works. Till now, any queries? Anyone? Okay. Okay. Which one should I? Can you please explain about database and vector embeddings? Yeah. So vector embeddings are it can be from a word or from a sentence. So you represent a text or a word or vector into a corresponding vector. Vector is nothing but array of integers. So here is the query is like, how does, we will go through this just going ahead. So how does photosynthesis work? Somebody asked this query. Then the embedding, vector embedding will be array of integers. It can be integer, means it can be positive, negative, and also can be decimal. So 0 0.2, 0 0.1, like that, and based on the dimension of the embedding vector, so vector embedding can be created. And on the other hand, database. So in database, we directly store the text. We don't convert that into embeddings. Max to max, we can create the indexes. That's by doing the hash keys, hashing, but we don't do the vectorization of the text. And there is no relationship between the hash keys directly. But here in vector embeddings, you can find the relationship, like the similarities between the vectors with the vector embeddings. Uh, okay, next. Sir, is it same like KNN? KNN means K nearest neighbor, like finding the nearest similarity. Yeah, KNN is a unsupervised learning algorithm, and which is based on the deep learning, deep neural network. So in KNN, we cluster the, we don't know the labels, how exactly the words are the points represent. So we cluster them, and we based on the number of k, which k can be 1, 2, 3. So if k is 3, then 3 clusters will be there. So based on that, we find out the similarities. So yeah, it's kind of similar to that, but not exactly. Okay. Okay, no other questions. Let's go ahead. Okay, so hope you can see my screen here. Yeah, so here we will go through like how exactly RAG works. So this is like before how it used to work. So user is there, user asks a query, and the query gets matched with the dataset, and from dataset the response gets generated, and user gets the response. So to give a little more insights into it, so there are two types of way a search mechanism works, or information retrieval mechanism. So there is one offline method and one online method. So in offline method, the documents which means the problems they are solving, like suppose say um, medical documents, specific set of medical documents which are not yet public and they are private, and those needs to be searched by uh, basically like say proprietary data, and we want some users to get those data. So those documents we ingest into a DB. So this is I'm telling how it used to happen before. So a normal database, it can be SharePoint also, like Microsoft SharePoint, and there will be user. So this process will be offline when the traffic is less, maybe in the midnight and all. So this time, why it is called offline? Because user is not directly interacting with it. Means this process is not directly interacting with the user. For user, it is offline process. It's not online. And why it is called online? Because when user interacts with this, so this happens online, means live. So user queries something, and the query gets hit with the DB, and it searches and it gets the response. So this before RAG, this used to happen like this. So user comes, user asks the query. So queries encoding will happen in the vectorization format that we call embedding, and those get stored into a vector database. And there are NLGs, like natural language generation. So this is how RAG got introduced in 2020. So it was proposed using, not using LLM, it was proposed using sequence to sequence model. So at that time, it was called NLG, natural language generation. So using sequence to sequence model and this vector similarity search between this ingested document encoding and the queries encoding. So we get top 3 results or something, and based on that, so the response gets generated and the user gets the response. So this is the uh, simplest explanation of how the RAG was proposed, and this can be represented as naive RAG, we call that. So initially this was the concept before RAG. So after RAG, this sequence to sequence LM language model got introduced, and this the user gets response using generated by this sequence to sequence LM. So this is from the information retrieval point of view. Now from LLM point of view, like why RAG is necessary for LLMs. So LLMs, as you might have known, it's a large language model. So language model is something which has more understanding of the language model, like how a language behaves, what is its grammar, how the sentence structure, how coherent will be the language. So if we train a language model for certain amount of time or certain amount of parameters, so after certain time there will be um, I'm forgetting the term. So there will be uh, um, generational knowledge coming up. So at that time we call that large language models. So large language models has few challenges when answering the queries. Of first, like the context window. So these are the challenges we will go through one by one. So suppose you have a set of proprietary knowledge banks. It's not there in the internet, and you want your users to be your clients to be able to query those documents and get the response. So if you query those in the prompt, if you add those documents inside the system prompt and you put it as data set as system prompt, then the context window might exceed. So generally, let's say the context window of LLMs are 1 million tokens, or earlier it was less, but now let's say it's more. Still, the if your documents are more, then the prompt size may increase the context window. So that is one challenge. Next is the high token count generates high LLM cost. So every time a user asks something and you query that, query all with the prompts and everything. So the input prompts go to LLM and it will incur in high LLM cost. So cost we need to reduce. So this is not affordable in the long run. Then LLM has a cutoff date. So if the LLM, suppose now Cloud 4 is there, or Gemini 2.5 is there, so it has a cutoff date. So based on this date, the LLM is trained. So they don't have any knowledge on what happened yesterday, like um, who won the IPL. LLM might not have known. So these things to it takes give means LLM cannot answer those latest data. So that is one problem with the LLMs. Then LLM can hallucinate. So LLM can answer what not at all true. It can made up things. So these are another problem. And the last one is there are few use cases where we want the actual, like fully sure that this is the answer and this we have proper evidence that what LLM is telling is correct. But LLM doesn't show that. There is no explainability or no citation as proof in case of LLMs. Like I am telling the crow is white, but there is no, or crow is black, let's say, and there is no citation I am giving. So then there is no credibility. So basically in medical field and research field, so this is much required. So these all are the few drawbacks of LLM. So these are mitigated by the RAG. So because of this, LLM get introduced with RAG. So here LLM along with the prompt. So it will be, we are augmenting. Okay, we will go through what is RAG now. Okay, till now, any other questions? Okay. I have doubt about context window and how it is related to number of words and how can I optimize it. Okay, so context window. So every LLM has a, okay, let me focus this. Yeah, so every LLM has a set of context window. Like if you give a prompt to the LLM, input prompt, so it has a limit of how much prompt it can take. So because LLMs are trained with a certain set of input prompts, so that we call as context window. So in context, there can be many things you can put, the prompts, the memory, or what was the past chat conversations. Those all things we can put in the context. So this context window is not infinite. So we have to give a specific, there is a limit on the context window. So that's why, um, yeah, number of words is not correct. So there is difference between words and tokens. So a single word can be multiple tokens. So let's say, what is a good, yeah, data set. So data set can be two different tokens. Data is one token and set is another token. So a subword can be a token. So yeah, so this is context window is calculated based on number of tokens. It's valid for usually chat GPT models, but in Gemini, I think they have introduced character based context window. So each character, each one based on that, the context window is defined. How can I optimize it? So yeah, we will go through how we can optimize that. Okay, next, sir, I have a डाउट, अगर मल्टीपल रिट्रीव चंक्स एक दूसरे से कॉन्फ्लिक्ट करते हैं तो सेल्फ कंसिस्टेंसी कैसे मेजर करेंगे? अगर मल्टीपल रिट्रीव चंक्स एक दूसरे से कॉन्फ्लिक्ट करते हैं तो सेल्फ कंसिस्टेंसी, yeah, so yeah, we will go through that, like what are chunks and all. Just remind me at that time. RAG की theoretical limit क्या है hallucination reduction में? Yeah, we will go through that. How can we chain multiple? Yeah, advanced RAG we will go through. How tokens are different than words? Yeah, I just explained that. Yeah, I think there is a bit lag. But yeah, if you still have doubt, you can ask again. I will explain. Okay, now let's go through what exactly is RAG. So till now we have got all the explanation and all why RAG and all. So now we will go through what is the behind the naming convention of the RAG. So RAG is named using three words: retrieval, augmented, and generation. So let's first talk about retrieval. So in retrieval, the term means it's kind of information retrieval. So there is a set of information present in a data set and all, and we are retrieving. We are not bringing in the entire information. We are retrieving specific set of information. Retrieving in the sense like, imagine there is a flower tree and you are plucking the flowers only. You are not pulling the entire tree. So this plucking things, specific set of information you are plucking, that is called as retrieval. So this is retrieval. Next is augmented. So here augmentation can be imagined like AR VR concepts. So augmentation reality and virtual reality. So in virtual reality, everything is like completely virtual, like a Meta's Quest 3, that headset if you wear and you will land into a metaverse, into a virtual world. So everything you see, that's completely virtual. So that is VR. But augmented reality is if you are in the actual world and the additional informations are getting augmented into it. Example will be like Iron Man's mask, that is augmented reality. So whatever Iron Man is seeing, the other informations are coming. So those are the Iron Man has augmented his visuals. Another real life example will be like the game Pokemon Go. So you can see the Pokemon animal sitting there. That is the augmentation. So the it's in the not in the real, but in the real world, in the mobile camera, we have augmented that. So here what we are doing, here we have augmenting the LLM's prompt with the additional information. We are adding more information to the LLM's prompt. So that we are calling as augmentation. So this one, retrieving the data, we are calling as retrieval. Then generation. So the final steps. So with this prompt and the context, augmented context and all, we are generating the response which is different from this augmented prompt and all. So that is the final part, that is called generation. So with all these three parts, so that's why it is called as retrieval augmented generation. Okay. Okay, let's see if any other questions. uh, okay, no questions. Next. Okay, so this is a simple linear step how RAG works. This first there will be query processing. So the query comes and we prepare the encoding or the embedding of the query. We convert the query into a vector that we call as query embedding. So here the query is how does photosynthesis work, and it will be embedded into a set of integers. So this is a vector representation of the sentence. So here sentence to vec has used sentence to vector. So there can be word to vector, there can be paragraph to vector, or there can be document to vector. Yeah, so you can represent anything as a vector. So why we are doing this? Because it's easy to compare vector to vector. Oh, why vector to vector? Because computer is easy to compute between integers. So to compare between text is difficult for computer compared to integers. Why? Because computer is made with binary 0 and 1. So it's easy to fast compute using integers compared to words. Then this is the query. This is the online process. So before that, the offline process would have happened. So where the ingestion would have gone into the vector DB directly with the same embedding which was used here to embed the query. So let's say to embed you have used the whatever algorithm you have used, the embedding model. The same model you have to use to ingest the documents. So with the same models in vector DB, we compare the similarity search between the vectors, the document vector and the query vector. Okay. Yeah. So after matching the document vector and the query vector, we get the top matches. Basically, you can say this is cosine similarity search. So if there are two vectors based on the cos theta cosine angle between the two vectors. So let's imagine this. So where is queen? So queen is here. So this is the XYZ axis. So queen to 0, 0, 0, 0, three-dimensional. So whatever, there will be a vector like this, and there is suppose mother. So vector will be another vector will be here. So here I am telling word to word. You can imagine that in sentence to sentence. So this vector and this vector are little bit similar, and their cos theta angle will be will show that how similar are they. Cos 90 is 1, so lower the angle, lower the value. Yeah. So that way we can find the cosine similarity. So if there is something feature here and we are seeing the cosine angle between this queen and feature, so the angle is higher. So in that case, they are not similar, they are dissimilar. So those documents will not be fetched while doing this retrieval. Okay, so this is one example. Next is context assembly. So we ask the query, we get the top three responses. Here, this also we can modify. Here, top three we generally call as top K. So K value is 3 here. So the query is asked, how does photosynthesis work? The top three matches came chlorophyll and light absorption, plant cell energy, and oxygen release process. Then based on these three, so these documents, this can be called as chunks. So we will go through that. What are chunks? And the query, those all will be fused into as prompt for LLM. So LLM will take those prompt and provide a response. So the LLM will think the user has asked this query, and I have got these responses from the document, from the dataset vector DB, and with these three and this prompt and whatever system prompt it has. So based on that, it will generate a response and will provide to the user. So this is like a in single line how a naive RAG works. Okay, this we already went through why RAG matters, accurate information, up-to-date knowledge, and source attribution. You can go through this website to read more. Okay, query time. No questions. Okay. Next, let's see if I missed anything here. Okay. Okay, this will go through. Next. Hmm. So what we discussed till now, those are simple array that is called as naive array. Naive spelling is like this: NAIV, naive array. So in uh, other than the naive array, there are different kinds of array systems. So I have broadly defined into four types, but there is no standard like the array are four types or five types or more. There can be more types. So let's discuss about advanced array. So in advanced array, what happens? Um, in every step, whatever this is the normal step we went through in naive array. So in advanced array, there will be multiple in between steps. So here the query encoding happens, but after query encoding, there will be metadata enrichment. Like the user is from HR department and he is asking the query. So I will be giving more emphasis on the HR related documents. So this metadata we can add, or we can add the last time the user has asked these things, this conversation history I have. So we can I can put that in the metadata. Then the query expansion. So query expansion and fusion can be combined. So in query expansion, in the same query, this is also called as HYDE rack. So here is similar, a same query, whatever the user has asked, that will be asked in different types by the LLM. It will generate the different queries, and it will do parallel search with the vector DB for the retrieval. Like the user has asked, what is the capital of India? Then the LLM can ask like different way it can represent like what can be the capital of India, or where where is the headquarter of India, like that. And query expansion that we went through. Then query rerouting. So if initially you have small number of documents and it goes to the vector DB and all good, all it searches and fine. But as the documents increases, the size of vector DB also increases. So you want to categorize your vector DBs and you don't want your query to hit all the vectors at the same time. So you may want to categorize the DBs. So here suppose say the user, you can add a uh, intent detection on top of the query, and you can say the user is asking about what is the capital of India. Then you can find the intent is general knowledge, general query. So it will go and hit the general uh, categorized vector DB, not into other which are the specific to HR or specific to finance and all those things. So in that way, we are reducing the retrieval time. So this is what we kind of the different ways to do advanced array. So this is only the retrieval part or the query handling part. So similarly, you can do in the offline part, the ingestion part. Um, any questions till now? Okay, sir, can you please share the link to the website? Okay, can anyone? Uh, I can comment here, right? Okay, it's a reg.soumendrak.com.
So I guess they are sorry, Somendra. I guess they are asking about the that link. The I guess you have the TensorFlow link maybe where
Okay,
you are
this
showing
one,
the
projector.tensorflow.org.
okay.
Yeah.
You can share with us. We'll share it with the users.
Okay. Where to click?
You, you can drop there also if in case you can, or in share in the private chat. You can also.
Okay. Thanks.
Okay. Sounds like we don't have much questions. We can proceed with the
So am I
session.
going too fast or it's fine?
I guess it's good. It's understandable. Like Mukesh is also commenting that it's understandable.
Okay. Thanks. Okay. So yeah, we are in advanced RAG. So we have discussed about how the query can be enriched further using these mechanisms. And yeah, next is the how we can do the chunking in the offline part. So I have chunking strategies. So yeah, so the document you are ingesting, so it can be like 500 pages long, or it can be 1-2 pages long. The chunk size in the sense, how we create the vectors, it's based on the chunk. So if chunk, you can imagine it's like a paragraph, but it's not. It can be or cannot be. Like chunk can be a simple word or a sentence or a document also. So chunking strategy is one of the important steps in RAG. So here, whatever the chunk we will be chunking strategy you will apply. So that chunk means you will divide your document into different chunks, and that chunk will have one separate embeddings vectors, and those vectors, that chunk will match with the query vector. So if your chunking is not correct, then in that case the vector will not match. Or let's say, suppose there are 3 paragraphs in a document, and you there is a whatever the query user asked, that is matching with the top one and the bottom one, but not in the middle one. So but you are giving the response in the middle one, in the retrieval result. So that is not the right way. So there are different ways we can do chunking. So first is the fixed size chunking. So here you just define what is your chunk size. So here we are doing character based chunking, and you can define the overlap. So between the chunks, you can say 200 characters are my overlapping characters. So suppose there are 3 paragraphs. So in the first paragraph, we'll have some contents. First chunk will have some content from the middle one. The middle one will have some content from both the top one and the bottom one. The bottom one will have some content from the middle one. So in that way, there is a chunk overlap. So if there is a context which is getting missed because of the chunking, so that can be captured. So it may not be generalized, so it varies from project to project. So there are some pros and cons. It's simple, predictable, but may break sentences and these all things. And there is another way of semantic chunking. So you can find the similarity between this is time taking. So here you find the cosine similarity between the sentences. So the previous sentence and the current sentence, are they similar? If they are similar, then put it into the same chunk. If they are not similar, then keep it separate. So this is sentence based. Similarly, you can do it in the paragraph based also if you want to do chunking based on paragraphs. So 2 paragraphs cosine similarity you can do. So to do cosine similarity, to find embeddings of every sentence or every paragraphs, it takes time. Yeah, so based on the number of documents, if you have lesser number of documents and this is not working, then you can try this one. This is complex, slower, and requires embeddings to find that how to do your chunking strategy. Next is document structure chunking. So if you have, this is like very rare cases where your documents, your client's documents or your documents are completely structured. Headings are coming fine, and there are tables are there, and all this content level metadata there are, or some different keywords which are perfectly defined in the documents. Then you can do this document structure chunking. So that is the best way. If you have proper documents, you can bypass these things and directly do this way, and it will be a good chunking strategy. But it is document specific, and you may have to manually parse the document to make it with same this structure. Okay, so this is yeah, this is different kinds of chunking strategy we can do in the advanced RAG. If you have even further documents and you can, what you can do is you can summarize the document and you can chunk those summaries. So this is again another, means you can put one LLM, or you can do, so there are two kinds of summarization: abstractive summarization, extractive summarization. So in extractive summarization, you extract the keywords and you do summarize, and which is not, which is probabilistic. But in abstractive summarization, you use ML or language models to do summarization. So extractive is faster and less costly compared to abstractive. So this way you can do the summarization and put it into chunks and put it into the vector DB. So this is how we can do the offline. So this part I'm talking about offline document to ingestion, how we can do in advanced RAG. Okay, any questions? Can we add images to the vector embeddings, and is it same like OCR? Yes, we can add images to the vector embeddings. So image, audio, video. So there is multimodal RAG. I think we have a example. Second half we will go through that. So we can calculate the embeddings from the images, audios, and videos. And is it same like OCR? Here we, it's kind of same like OCR, but that is handled by the LLM. So we are not doing OCR here. OCR means object character recognition. It's converting from image to text. So we can do or we cannot do. It depends on project. So if you have a large number of, suppose say PDF with scanned images, and that that way it is easy, means it's less costly for you to do OCR and prepare the extract the text and do RAG on top of that. But you have, let's suppose say 2-3 images, or the images which don't have any text in it, but it has chats and all. So in those cases, you can directly give it to LLM. Okay. Next. So you do the query enrichment, you do the ingestion enrichment, then you get the retrieval results. Then what you can do after the getting the retrieved results, then you can do the re-ranker you can add. So based on the top 3 results or whatever top results you got, you can re-rank them based on how relevant it is to the query. So that you can add another some rule-based mechanism or probabilistic mechanism. You can re-rank those, and again the retrieved chunks, means 3 chunks you got, you can summarize those 3 chunks, or you can here 3 chunks I am telling, assuming the top k you have given is 3. So you can say 10 chunks you can also retrieve, like give me all the top 10 matched chunks from this query and document matching. So if you got 10 chunks, then you don't want to push all the 10 chunks to the LLM. So you can summarize those and put to LLM, like here is your system prompt, here is your query, and here is your summarized context from the DB. So that way you can do. And the third one is these are not the only thing. The exhaustive list of the enrichment we can do in advanced strategy. So these are few of the examples. So the third one is fusion. So in fusion, it's kind of similar to what we discussed in query expansion. So the query which the user has asked, so two parallel queries, create different queries from the user's queries, and ask the vector DB to match. And after getting those results, and you find that wherever your retrieved documents get the rank. So let's say, to make it simplify further, so query 1, which is the user's query, query 2, 3 are the queries generated by the LLM, and those 3 queries got matched with the vector DB. And suppose there are top k we have done, so let's say 4 to make it easy. So 3 queries came and 4 results came for each of the queries. So suppose there is a one document, one chunk in which the that came in top 1 in all across the 3 queries. So in that case, that will be given higher rank. And similarly, so suppose there is another uh, chunk which came in, suppose say in second, third, or fourth position, and they will average out, and based on the average of the rank position of the chunks, so the top three or whatever is defined, that will be given to the LLM. So that is fusion, and based on this, the generation can be done. And here also we can do further thing, like you can give more system prompt related changes to the LLM, and accordingly the response will get generated. So this we discussed about. Okay, if any questions, please ask. Okay, this we discussed about advanced strategy. Okay, so this is like a simple concept, I think we should know. This is a digress from the topic, but yeah, to make you, this is a foundation class, so to make you fundamentally clear. So if LLM gets combined with tools, so that we call as AI agents, like thumb rule. It's not necessarily, it is like a easy way to understand. LLM, if you combine with dataset, that we call as RAG. But if LLM combined with both tools and dataset combined, that we call as agentic RAG. So RAG is a information retrieval mechanism done by agents called as agentic RAG. Agent means done by tools with agents. Okay, so this is a concept to know. Okay, what are the primary considerations when choosing a chunking strategy for the vector DB in this architecture? Chunking strategies. So it depends on project to project. So there may be, so you can start with simple chunking strategy, fixed size chunking, or yeah, this you can start with. Then if you face issues, what kind of issues? Let's say, there was a troubleshooting guide. Yeah, so there are different kinds of issues can come, like the retrieval quality can be poor, latency can be more, API costs can be more. So depending on this, you have to change your chunking strategy. So there is one um, mechanism. So you can combine both these using recursive chunk splitter from LangChain. And what was the question again? When choosing a chunking strategy, okay, what are the primary considerations? Yeah, I think these are the like basic considerations. We will go through each of those, like what are the challenges and all when throughout the course. Okay, okay. Let's now discuss about the RAG evaluations. Okay, so there are three basic fundamental things in one RAG question which the user has asked. We call that as query. Then the answer which the user has got from the LLM, and the context. Context includes both the prompt and the retrieved information from the vector DB. So these three, uh, we can use these three to define the metrics and to find out what is the problem with your RAG. So this means you have created RAG, and how to know that whether your RAG is working fine or not, whether your users are good or not. So to evaluate those, we need to have RAG evals. So suppose there can be issues like your users are asking some different questions now. Your like drifting happened, like the user data drift happened, or the query drift happened, um, or the document is updated with new data, and the user, whatever the data was coming before in top result, it's not coming in top now, it's coming in bottom. So to handle those things, we need to have evals. So as an AI observability architect in PepsiCo, so I work with evals like my day-to-day job. So there we consider like how way we can monitor the RAGs are working, LLMs are working fine or not. So here we have query, context, and answer. So these three components, and to some extent you can also add ground text or ground truth data or golden text. Yep. So, but that we will discuss if that is mostly these three will be able to handle most of the cases. So if you have created RAG and these are the basic foundation metrics you should have. First one is retrieval precision. So here this will find out like how many retrieved documents are actually relevant. So you have asked query and the documents or the chunks got retrieved, means how many are the relevant chunks relevant to the query the user asked. So those you can find out using retrieval precision. So relevant retrieved by total retrieved. So total, suppose three chunks got retrieved and out of those three chunks only one was relevant and the rest two are not relevant. So your score will be 1 by 3.33. So retrieval precision will be 0.33. So it's a based on your project. Again, we cannot say 0.33 is a poor score. So based on your project and your use case, you have to define the threshold, like what is your precision score. Similarly, for retrieved recall, oh, there was this. So 10 docs 8, so 8 by 10, 0.8. So zero point 0.8 is the retrieval precision here. So similarly for retrieval recall, so how many relevant documents were actually found? So total relevant available, like we have total ingested documents which are related to say um, finance. Finance is a broad term. Let's say cyclones in Odisha. So out of those 20 relevant docs, only 8 got fetched. So the 28 by 20 will be zero point 0.4. So how many relevant documents were actually found? So only 8 found out of the 20 relevant documents. So this is like how many totally available in this vector DB. 20 are available in this document. But this one is how many retrieved. So if 3 retrieved and 1, so score will be 0.33. But if you have 20 are there in the vector DB, you have ingested and 1 found, then your score will be 1 by 20. So 20 should not be coming here. 20 are there, but you found only 1. 3 retrieved, but you only found 1. So that is precision. 20 are ingested, but you found only 1. That is recall. So this is retrieve recall, retrieve precision. Okay, any doubts on this? Okay, no doubts. So these two are the basic metrics you should maintain when starting with RAG. Then the primary RAG, then the next version of metrics you should have. So these two we just did with the retrieved and finding the relevancy. So how we did it? The answer and the question using only the Q and A, query and answer. But this one, we are adding the context into the picture. Query, answer, context is coming into the picture. So in context, like how well retrieve chunks address the question nets. So here someone asked health benefits of meditation and context about stress reduction and cognitive benefits. So that is high relevance. So when the answer seems to be off topic or incomplete, so then this context will be coming into picture. So the user has asked something and the context means this one, what we get from the vector DB and we add that into LLM. So for LLM, it is the context. So that we are calling is that context here. So context, what is the relevance here? So relevance score. So how well the retrieve chunks address the questions needs. So here we are not comparing the answer here. So retrieved question and the context. So the question was asked and retrieved context. Question was asked, query was asked, and what is the context? So is the query and the context, how relevant are they? So that we compare, evaluate. So we are not going to the response here, query and the context. So here context relevance, we tell like that. Next is answer and the context. So whatever answer has given, how grounded it is with the context. So we have given one context to the LLM, and let's see, and it whether it's giving something out of the context. So that is whether it's hallucinating. So that all things to identify. We use this matrix. How faithful is the LLM to the provided context? Okay. Next. Answer relevance. So question context, and answer to question. So how directly the answer addresses the specific question. How does compound interest work? So this means answer addresses the direct to direct answer to question. So because I asked this, whether the answer is relevant to the question. So how means all these things are good, but how do we identify means who will evaluate this? Like these things, like whether it's relevant and all. So in that case, we use a mechanism basically called LLM as a judge. So one LLM will judge the another LLM. So the main LLM. So there will be another LLM who will be for evaluation, which will be judging this LLM. Let's say, let's move it, make it LLM. Yeah. So that mechanism, when LLM judges another LLM, that we call LLM as a judge mechanism. So this way we found out the scores and metrics um, using LLM as a judge. And if you complete this first and two, you can go to the third one. So context support, advanced array relationship, like does the context contain all the info needed to support every claim? So here, um, this is another higher level of identifying whether the LLM is hallucinating. So suppose someone asked, who is Narendra Modi? And let me go there. The user has asked, who is Narendra Modi? And the LLM has replied here that Narendra Modi is the Prime Minister of India. He is from Gujarat, blah, blah, blah. And he was also the Chief Minister of Gujarat. So here the LLM has, the evaluator LLM, the LLM as a judge, it will see the question and it will see the response, and it will see in the response the actual LLM. It has made three claims. So what three claims? The first claim is the Narendra Modi is the Prime Minister of India. Second one is he is from Gujarat. Third one, he is the Chief Minister of Gujarat. So these three claims it will identify, and it will match with the retrieved information from the vector DB. So whether all these three are in the context, so that thing is we are showing here. So context support, does the context contain all the info? Okay, am I going too deep or? Uh,
Uh, Soumendra, I guess it's great. You are explaining like it, and it's very detailed way. Like for many of us, it's new some concepts regarding writing.
mhm.
Also, Soumendra, if we can pick the previous questions, I guess there were some questions regarding to chunking. Let me bring that in the screen. Yep, one from Satyam,
Okay,
like he's about the
I
chunks
have a
conflict.
doubt. अगर multiple retrieve chunks एक दूसरे से conflict करते हैं तो self consistency कैसे measure करेंगे? हाँ, so in this case, conflict करते हैं means suppose someone asked who is the Prime Minister of India, and in one chunk you have mentioned Narendra Modi, and in another document, suppose say old document, and you have mentioned that Dr. Manmohan Singh is the Prime Minister of India. So you can, here the main problem will be the documents need to be updated. We cannot do anything here. Um, Means if you have done some agentic search or no need to be agentic, if you have some tools in your RAG, like web search tool, so in that case it can search the web and verify that. But if you have not implemented that, then only way is to you have to update your documents. You need to tell your clients. So you have to showcase that explainability. So if the LLM is telling Dr. Manmohan Singh is the Prime Minister of India, then you have to showcase like why it shows, and then you can quickly identify because the document already has, so it has shown like that. So the documents need to be updated. Okay.
Also, we have another question from Akanksha. She's asking about how we can chain multiple rack systems.
Yeah, multiple rack systems together. Multiple. Uh,
I guess what I can understand, she's asking about, let's say we have some document retrieval engine, another we have some image retrieval engine, how we can connect both. I can say if you're in the live stream, you can like get a clear concept and ask clearly what you are like want to ask.
Yeah, if that is the query, then we can use hybrid rack. So in hybrid rack, uh, I think she asked multiple rack systems. So that means there are different rack altogether. So you can do parallel search then, like you ask the both the rack at the same time. But why do you want to do like that? Um, yeah, I think hybrid search should solve this. So in hybrid React, what we do is like there is a keyword search or the traditional TFID for BM25 based search, and there is this LLM based search with the vector DB. They get the response and all, and at the end we combine those and give to the LLM, and it provides the response. So in that case, we get the best of the keyword search and vector embedding matched search.
Okay, I hope Akansha that answers your question. Also, Sumendra, we don't. I guess we don't have much more questions. We can proceed with the session.
Okay. This I think let it be. Okay, these are like what can be used as vector DBs. So don't go by the numbers. This website I have created just yesterday, means LLM has created with vibe coding. So don't go. These are the some popular vector DBs and embedding models. These are some few other embedding models. So OpenAI's text embedding ADA 002 and BERT-based Google's bidirectional encoder model. So here the only thing should be considered is the same embedding model which we are using in the query encoder part. Here the same model you should be using in the document encoding part. If both will be different, then the vector similarity search will not work, and you will get different. You ask something, it will provide something else. Chunking strategies we went through. This I think not needed for foundation class. Um, Yeah, I think if we have any queries, we can go through, or we can go for a break and we go with implementation. Yeah, after the break, can we have hands-on session? Yeah.
Okay, Sumendra. So we can take a break for now. Like 5 minutes break will be enough, or we can take
10
10
minutes.
minutes. Okay. So, folks, we are having a 10 minutes break here, and we'll be back in the session by sorry, 11:30. So till then, you can grab your coffee or get freshen up to do a hands-on.
And if anyone is remain fresh, we can come on chat and let's chat about today's session. Mm. So can I have some feedbacks? Okay, there's one. So can we have an hands-on session? We are planning an hands-on session. Hi, that is not possible, brother. Some things are kept to be delivered by experts, not me. Hands-on session we are planning. We are planning somewhere around June end or July. We will notify if we will notify surely on our website and all the channels.
Uh, Soyam, I guess he's asking about today. Now we'll
Oh,
have
today's
hands-on session.
yeah, we would be having hands-on
Yeah.
just after. Okay, okay. I thought he's asking about the offline one. The session is very helpful. Thank you, Shubham, for the feedback. Break time. Okay, this is take a quick breather. Want deeper inside. Who is Satya Prakash Mohanty? Or is this a bug on our platform? Okay, he's from our team. Uh, got it. Let me go through some doubts.
Okay.
Okay, so hello everyone. Once again, welcome back to the stream. We have just completed the theory session of RAG, and now we'll have a hands-on session. Swayam, you can carry forward and let's
Hey, hi
start the hands-on
folks,
session.
welcome back. I guess you had your cup of coffee, tea, breakfast. Like literally had my breakfast just now. So, before starting off the hands-on session, let's hear some doubts if anyone has any. Because I don't want that you go into the hands-on before any doubts. So, Soumendra is already here with us. So, if you have any doubts, even if you have no doubts, just confirm me on the chat so that we can move forward. Mm, also have this. Okay, cool. No doubt for now. Uh, we would be sharing you some collab notebooks. Okay. We will be showing them. I'll be showing us a QR. Also, let me try to get. If someone is watching us over the laptop or their desktop setup, I will have the link for them as well. Great, great. Thank you, Shubham. Thank you, Dev Explore. Just give me a second. Great. The you have pasted. Okay, I will paste. Thank you, Gitanjali. Guys, you can scan the QR. Uh, I'm also sharing the URL directly in the chat as well. If someone is on their laptop or desktop setup, let's just wait for a while.
We can, I guess, start. Uh, Savendra, we will start with the V0 right first, then we'll move forward to the V1.
Yes.
Cool. Then we have shared the. I please, folks, please confirm on the chat that you have the notebook open so that we can move. If someone is facing any difficulties, please share your problem. We'll try our best to solve it here. Please confirm if everyone is able to open the notebook easily. Sumendra, let's just wait for a little confirmation. As we get one confirmation, we will move ahead that they were able to open the links either through QR or the. Yeah. Okay. Cool. We have confirmation. Let's start sharp at 11:36. Okay. We'll wait for a little more time for people to come. Cool, then let's start. Handing over the stage to Soumendra. Please, sir.
So am I sharing my screen?
Yeah, yeah, we can see your
Yes,
screen.
Okay,
Sumit.
okay, nice. Okay, let's start with some hands-on session. So in this one is a V01. So V01 is pretty simple, naive. So hope you have access to this notebook. So we are installing um, Logguru here, but it's not needed. Did I use it? But it's fine. So you can click here, it will install it. We are using UV as package manager. UV is fastest package manager in Python now. So and UV is compatible with pip. So you can install any package library like this. And these are the few of the import libraries we are importing. So these are already installed in the Colab, so no need to. So you see, I am not importing those here. So import Google. These are distracting. Yeah. So import Google Generative AI, Gen AI, Sentence Transformer, and cosine similarity. This is to find the similarity between vectors. And okay, let's go. And this is the SQL.
Soumendra, can you just increase the zoom percentage? I guess it won't be visible. Yeah, this is fine. Oh, no, no, this is very large. This is very large. This is fine. This is fine. I guess this is fine. Can anyone from the chat confirm, please? This should be visible now. Yeah, yeah, this is visible. Please continue, Soumendra.
Yeah, we can max go till no max go till here. Okay, no, I can even go further. But yeah, this should be fine. Yeah, so we have installed this. Then this one I will delete after this session. So we have this API key. Um, we have this we need to set up. Next, we are building a knowledge base. So knowledge base in the sense like this one. In the sense this vector DB we are calling it as knowledge base. So in knowledge base, we are using Gemini 1.5 Pro model, initializing the model. So here the model is this LLM. Here we are using Gemini 1.5. Sentence transformer, we are using Mini LM L6V2. So this is the embedding model. So which will convert the query into the embedding and the documents of the knowledge base into the corresponding embedding. So this is the current knowledge base now. So only how many? 11 sentences. And yep, so mostly about Paris and all, and last one is about me. Then these are like how to retrieve context, generate response, react with Gemini, and that's it, done. So this is like in very simple way how to mimic this whole thing. Okay, so let's go one by one. So user is whom? User is you or I. Here input whatever we will ask here, so that will be our user query, this one. Then answer, react with Gemini. So react with Gemini is here we have context and response. So context is this context and response is this one. So augmentation is context here. So how we are getting context we are getting by retrieve context is here. Retrieve context is taking query knowledge base and top k is 2. So retrieve context means this one. Okay, let me do context here. So this is taking query knowledge base. So this is taking query and this knowledge base means whatever we have given. So this we can tell as knowledge base and the top k. So top k is 2 here. So top 2 results which will get match between query and the knowledge base, that will we will get. Okay, so let's first do the encoding of query. So embedder, what is embedder? Embedder is here. Embedder is sentence transformer. So we are using this all mini LM L6v2 to convert the query to vector. So query embedding will be the vector representation of the query. So vector representation means the uh, again the list of integers. Then context embeddings, again we are using the same embedder, same embedding mechanism algorithm, and we are giving the knowledge base. Knowledge base means here this one. So all the sentences we are giving in a list, and here you see we are giving list here. So already what it takes input as a list of string. So here we already have list of string, so we are not giving any brackets here. So direct knowledge base and context embeddings will be here. So here we have only one vector, here we have 11 vectors. Okay, we got our embeddings ready. Query embeddings got ready here. Document embeddings got ready here. Let's modify here. Query embeddings, document embeddings. We got here. Array context. No context. Okay, it should be document. Yeah, but anyway. Then we got similarities. So we are doing cosine similarity search between query embedding and context embedding, and we are finding the similarity each one. And so cosine similarity you can read over internet, like I also explained, like in between vectors how to identify which two vectors are more similar with each other. So this will identify between the query we will ask and all these vectors which vector is more similar, because we have given top k as 2, so it will find the top two most similar sentences here. So top indices will give top two, and it will return the knowledge base like it is returning the indices. So knowledge base is a list of string. Let me zoom out a bit. So knowledge base will show top k minus 1 means -2 to end. -2 means in Python this is the list, what we call it, slice operator. Yeah, -2 to end. So -2 means like from the bottom two elements. 0 minus 1 -2 it will not include. So yeah, 0 and -1 it will took. So bottom two, and it is in both sorted, I think. So top indices will be the bottom two ones, and it will return those. That's why they reversed it. So the bottom one will come on top. So this I will execute and I will show again. So this is just to again focus the theory. So this, where did we come from here? Here. So we got the context now. So we uh, got the query embedding, we got the knowledge base embedding, and we find the similarity, and we get the top two retrieved uh, knowledge, top two retrieved result, and we got the context. Then this query with the context we will give to LLM. So we got the query embedding, we got the document embedding, and we got the context embedding. Should be context, yeah, context, and we give the context with the query to the LLM. So context is here, and the response. Okay, how we are getting response? Response is here. So response, we are giving a simple easy prompt. Here we are giving, hey LLM, this is your context, join context, question is this, and your context is the top two sentences, matched sentences. Then the response. So response, we are asking the model, what is model? Model is this one. So this is a Gemini 1.5 Pro model. So model will generate the content based on this prompt. So with this context, it will try to answer this query. So context, question, and answer. What is the answer? then it will return the response here, and we are returning the response text here. So it will come where? It will come to here, response. So we give query context, we get the response, we are returning the response. It is called where? It is called here. So we got the answer here, and the answer will be here. Okay, now let's execute. So we have executed till this. Okay, let's zoom out a bit. It will give better visibility. Okay, query, let's ask where is Paris? So it is here. So it's telling Paris is the capital of France. So, okay, we didn't get much info. Let me add more breakpoints. Query embeddings, or I can directly print the context here. What did I import? Logger. Okay. Logger.info retrieved context. Then I can showcase here. No, I want to showcase the query. Okay, here we can do like this. Query. So it will be the query. Here also we can do like this. Okay, now execute again. Where is Mona Lisa situated? Okay, so here the context we got the Louvre Museum house, the Mona Lisa painting, and Notre Dame Cathedral is a famous Persian landmark. We got these two from the context, so you can see this, the Louvre Museum. It has Mona Lisa in it, and where is Notre Dame? Yeah, this one. So it understood that I am asking where. So it got these two responses as context, and based on the LLM got this context, and based on the query where is Mona Lisa situated, and it gives the response Mona Lisa is situated in this museum. So here you see we are not using any vector DB here. So on in the fly we are doing here. We are getting the encoding, and we are directly cosine similarity matching, and we are giving the response. So no vector DB here. Directly we are comparing and giving to LLM. Okay, so let's ask another query to showcase this is working. So let's ask who asked questions. Let's see. Gitanjali. Okay. Who is Gitanjali? Okay, so it says the context provides no information about Gitanjali. We know about Soumendra because I have one sentence here, but nothing about Gitanjali. Therefore, we cannot answer who Gitanjali is. So this LLM is because we have used RAG, so it's we are giving the give the response only whatever context you have been provided. Maybe internally somewhere it is there. Means I have not given any prompt, but it should be somewhere. So it's not giving the response of the whatever we are giving any asking any question out of the context. Okay, so if we would have asked the same to LLM directly, then it would have hallucinated and told something like Gitanjali is blah 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 like that. So if I ask who is Soumendra, then it got the top two responses here, and this one is not related, but top two we have added. So first one, it matched perfectly. And when I asked who is Soumendra, it's giving Soumendra is and blah blah. This one. Okay, so this is just simplest example of how to implement RAG. Any questions on this? Let me zoom it out a further. Just let me summarize it again. So we are using GenAI sentence transformer cosine similarity. We have defined the model Gemini 1.5 Pro. Embedding model, we have used sentence transformer mini LM knowledge base. Here we have used these 11 sentences as our knowledge base. Then here we have defined how to retrieve the context, how to generate response, and how to do RAG with Gemini model. In retrieve context, we have found the similarity search between the query and the context. Query and the context, we have found the similarity search and found the cosine similarity, and we got the response in context, and we have given this context to LLM, and the LLM has got generated the response. We have skipped the vector DB. Directly, we have done the cosine similarity. So this knowledge base are 11 sentences. This query we are asking on the fly dynamically. So this is, if this we are clear, then we will go to the next LLM, next example. So you should be fully clear on this example. Any questions on this?
I guess we have one question from Shubham. Uh, he's asking like we're using Gemini, so you can search directly from its own knowledge. How can we restrict to our knowledge base
Yeah,
only?
here most of the time, like it gets handled. Means I have tried with Chat GPT models, means OpenAI models. So we say like if you don't find any answer in the context, then reply I don't know the answer. Like that, we give in the prompt, or if that is not working, then we have to tweak a prompt a little bit. So such that the LLM will be grounded with the response. It will not hallucinate. So prompt tuning is the only answer, because this LLM, it can answer anything. So we have to ground the LLM, okay, with the corresponding RAG data set.
I guess we don't have much questions. I guess folks are going through the code. Okay.
Okay. Any other queries? Simple thing, or if it is not simple to you, you can ask, because the next one is a little bit complex.
We guess we don't have much more questions for now.
Okay. Let's,
Folks, if you have any questions, you can ask in the chat, or else we can keep the questions at the end, and Somendra will ask it after the second code explanation. Okay, Somendra, we can go ahead.
yep. So this is version 1. You might have the link. So in this, yeah, any question? Okay. So in this,
Uh,
we will go through, we will do a multimodal RAG. Multimodal in the sense it will search both in text and image format. Yeah, so um, this I have, there was already a tutorial, so I have just copied that. So yeah, we will go through this, like how everything happened. Okay, what all things are there? Multimodal RAG. Hmm. Okay, so let's start with first one. So here we have to add few extra libraries, install and import dependencies. I have already connected, so we don't need GPU machine here. CPU is fine, and let's click on plus play. So these are all installed now because I have used Quiet here, so it's not putting any logs. But yeah, then this is Google Cloud related settings I have given. So I have created a Google Cloud project because I used Gemini here. So from Google Cloud, I have got this project ID, and this when I clicked on this auth user, so it will ask the pop-up for the to log in using your Gmail ID. So I think I have already done it. When did I do it? So I have to. So it will ask again. I will do this and I will get back. I'm stopping screen sharing. Just a second. Okay, it didn't ask. Entire screen share. Yeah. Okay, so this I have executed. Then we are using Vertex AI. Vertex AI is the, you can say, AI platform from Google Cloud. So using Vertex AI, you can access the models, LLMs of Google. So we are importing Vertex AI, and we have initialized the project. Project ID we have given, I have given in my Google Cloud, and region by default it came like this, so I kept it like that. So till now we have just done some housekeeping tasks, no, nothing. This also will do the same. So here we have initialized a logging mechanism, and from here we are uh, extracting the zip file, and inside the zip file, what we have, um, we have a PDF file. I opened it. Yeah. So this is a PDF file, clouded judgment, OpenAI updates. So this is a blog post from, I think, the original author who has prepared this tutorial. And inside that we have few images. Yeah, so we will be here. Our goal is the RAG will answer any questions. Sorry, any questions we ask, not only in the text but also in the document inside the, sorry, inside the image. This is image, this is not text. Oh, sorry, just a second. Yeah, so we will execute this. So as soon as we run this, what will happen? So you can click on this folder icon. So you will see there is one CJ zip got downloaded, and we have written, means the file, the resulting file over here, the CJ zip. Then we have used the zip file library of Python, and we have extracted the zip file, extract all we have used, and extracted to here. CJ has the PDF and the corresponding the images. Okay, so next, LangChain we have used here. LangChain is a popular library, more than 100,000 stars in GitHub, and we have used LangChain here to do the RAG. So, and we have used PyPDF loader. I think PyPDF is the library which is wrapped by LangChain, and we have used loaded the PDF file, and we have found tables and text. So I think there is PyDocx. So in that docx also, or let's say I think they have done it from where D is, what is D docs is loader load. What is loader? Loader is PyPDF loader. Okay. So this PyPDF loader object they have created loader, and they have loaded, and each page content they have put it in text. So each page will be stored in as a uh, um, what is this? So string of list of strings opposite. So like that text, we got the text. Then if we, this is the first page. So it starts with clouded judgment, ends with start building out AI, type your email. Okay, let's see. Clouded judgment, it starts. Start building with AI. I don't know. I'll just type your email. Okay, this one, I think somehow it is taking at the bottom. Yeah, so this one page is in one element of the list. Okay, so this is the first element of the list, text 0. Next, so length of text, how many pages are there? 21. Here, how many pages are there? 21. Here. Next, generate text summaries. So we are generating text summaries here. Every page we are summarizing. How we are summarizing? We are just creating a prompt text. So we are using LLMs. Which LLM you are using? So yeah, Gemini 2.0 Flash. So here prompt we are giving you are an, so this prompt when it starts with you are an assistant, that means it's a system prompt. So there are three kinds of prompt, three, right? Yeah, or yeah, three. So first is the system prompt, then is the input prompt, and then is the output prompt or the output response. And there may be, yeah, so this is the system prompt. So here we are giving the LLM like what it is, which role play it will be doing. So we are telling you are an assistant tasked with summarizing tables and text for retrieval. So these summaries will be embedded and used to retrieve the raw text or tabled elements, give a concise summary. So we are giving the LLM our plan that we will embed the text and we will um, use that to find the text inside that, any matching and all, give a concise summary so that tabular text is optimized for retrieval. So for retrieval, give us the text. So tabular text and the element. So element should be somewhere here. Yeah, here. We will go through that. And then based on this text, the LLM will summarize this. So prompt, they are using LangChain, I think. Prompt template. What is prompt template? Prompt template. Prompt template. Okay, I have to search. Yeah, this one. Yeah, LangChain prompts. So okay, let me zoom in a little bit. Initially, it is good to zoom in. And right, yeah. Yeah, now I think it's better to see. Yeah, so we got from the LangChain, we got the prompt template. So prompt text is this one. Then this here we got the prompt, but here we have a placeholder. Where? Here. The prompt is not complete yet. So prompt we got this, then empty response. So runnable lambda is a LangChain concept. So if are they using LangGraph here? No, I think. Okay, we will see. Runnable lambda get imported from here. Okay, so AI message again from, it should be, yeah, LangChain core messages. So yeah, so here it's telling, so if you don't get any response from LLM, then respond with this empty response. Yes, it is handled here. We will go through this. So error processing document will be the content here. Okay, text summary chain. So we are creating a chain here. So LangChain has the concept of chain here. So chain is created using this, what is this called? Bit operator or pipe operator. Yeah. So this is the model. So this model is a consolidation, like it's created using combining multiple things, but multiple things. So Vertex AI is the library we are using to use the models from Google. Here we are giving temperature. Temperature is 0. That means we want the response to be accurate. We don't want the model to give something out of his own, or we don't want any creativity here. So temperature varies between 0 to 1. So 0 means accurate to the point information. 1 means it, it can vary. Like suppose this is a sentence, you are an assistant task, and after that you leave it. So this can be with, to, for, or anything. So if it found that width is the here I am telling how temperature works. So if width is the highest probable of the next element will be width. So if the temperature is 0, it will go with width only. But if the probability temperature will be, let's say 1, then it will go with the some different. Maybe it will go with 2 or by, like that. So if you want the model to respond with more creativity, and you want some new way of answering, new way in the sense like some different kind of answering, then you can go with more high temperature. High temperature you can go till 1. So 0 to 1 your temperature setting should be there. So there are few other settings also, like top P, top K, you can provide here. I think we have not used those. Yeah, that's fine. And yeah, so but here if you why we have given 0, because we want the response, because this is array G, so we don't want any creativity here. The data which the model will summarize, this is summarization, so it should be only corresponding, it should be accurate. It should not be anything which is other than the text which we are giving the model. The model name is 2.0 plus. Maximum output tokens we are giving is, so when you do summarize, the input token can be like anything. It cannot be also anything. It should be in between context window. So within the context window, the input should be there, input size, input token size, and the output here we are giving maximum output tokens is 1024 tokens. Okay, so the sum, that means every page should be within 1024 text tokens, and token each can be word or subwords with fallback. So suppose model doesn't able to give any response, then fall back to this empty response, this one, error in processing document. Okay, then summarize chain we are creating here. So this is the model, and we are creating a chain here. So we are creating chain using the element. So in how you read this chain is you go from left to right. So first we are creating a lambda function. Lambda is anonymous function in Python. So generally how we write function in Python. This is a Python. This is a function. Define and generate, and this is blah 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 parameters. So this is a function. So lambda is the anonymous function, but here we are using lambda as uh, this is not a, sorry, this is not a anonymous function. So this is a dictionary, and here we are giving key as element and value as the lambda x as x. So whatever x will be provided, so this will be used as the value here. And this whatever output means element colon whatever x value, this dictionary will be given as a prompt to this. Where is prompt is this one. So this will be given as input to this prompt. So what it will take element. So element is here. So this element will be replaced with this value. Whatever the x value will be, this will get replaced. This will replace the element thing here. So the entire prompt will look like you are to this. Okay, next the model. So model will take prompt as input. So here the model is here defined here, and it has, I think, internal mechanism to take this prompt as the input. Then str out processor is string, so the chain will give output in string format. Okay, this is the final thing. It can be JSON format or some other formats are also there. Yeah, so here we are expecting in the output parser should be in string. Okay, so I didn't see any queries yet. Okay. Okay. Uh, can you explain about top K and temperature? Okay. Temperature, I think I explained. Top K. Top K, to understand top K, we need to understand top P. It's both, if you understand in parallel, it will be easy. Top P. Yeah, just a second. That should be a good diagram somewhere. Is it? No. Good diagram, good diagram. No. Okay, I am not finding one. Oh, these are also again tough. Okay. Okay. Uh, okay, I think I remembered now. We can show with one this diagram. Yeah, yeah. So top P, top K. So top P is the uh, top probability. P stands for, you can say, probability, or what is the probability of okay, leave it. So let's see this one. Mat table chair building, mat table chair building car. So these are the Word documents, and okay, so this is on the context of LLM. So suppose there is a sentence and the sentence got stopped there, and what should be the next word of the sentence? So that LLM can identify using this top P and top K parameter which we define. So top P means, so top P here, suppose we have given, what we have given? Uh, let's say we have given zero point 0.7 here, top P. So that means only so these are the probability of the next word. So uh, the LLM finds the probability. So the next word should be becoming mat is probability zero point 0.4. The next word becoming table is probability zero point 0.3. Next word becoming chair, like that. Okay, so if top P is zero point 0.4, I think let's do it 0.9. So if top P is zero point 0.9, then these three will be coming into the picture. Like the all the top scores, which by you some what is some add them. So zero point 0.9 is our top P, and if you add this, so zero point 0.4, yeah, it's less than 0.9. Okay, let's go ahead. Add zero point 0.3, next word. What is the probability? 0.3. So add zero point 0.4 plus 0.3, 0.7. Is it still less than 0.9? Yeah, let's include that. Then add the next word. Uh, 0.7 plus 0.15, so it's 0.85. Is it still less than 0.9? Okay, let's include that. Then 0.95 plus 0.1, what it is? It is 1.05 now. Is it less than 0.9? No. Then only these three words will be used by LLM to fill up the next word. So LLM, you know, right? So it sequentially it adds the new words. So out of these three words, it will find one. So this way, then if you say that temperature is 0 here, so it will pick this one. So if, and top K will also come to picture. So this is top P. So in top K, we will explain. So K means directly, suppose say 4. So you have given 4 here. Then the the top four results will come into here. So 1, 2, 3, 4, fourth one. So this is the top 4. So then again, you have given temperature as 0. Then this one will be picked. Temperature as 1. Then any of these 4 can be picked. Okay, hope it is clear.
I guess that answered your question. So,
Okay.
next to that one, Satyam.
रिट्रीवल और जनरेशन रिजल्ट्स में सिमेंटिक ड्रिफ्ट को कैसे डिटेक्ट और मिटिगेट करें ओवर लॉन्ग कन्वर्सेशंस. रिट्रीवल और जनरेशन रिजल्ट्स में सिमेंटिक ड्रिफ्ट को Semantic drift in the sense long conversation.
Satyam, if you're in the chat, you can clarify your question. Also, I guess Soumendra, which asking, he might be asking about like how we can optimize the LLM, like in the longer conversations, like it doesn't fail to get the history of the last context.
Yeah. We need to means in LangChain it is GG. We can give the conversation history as memory to the LLM.
No, no, no. I will tell you what exactly semantic drift is. So this is
Hmm.
one common problem. Semantic drift is basically when few words mean some semantic. Basically, what is semantic? What is the meaning of the sentence, right?
Hmm.
So semantic drift basically refers to the situation in which few words means something else when put in one way and something other than the first when put in some other way. That is what exactly semantic drift means, as much I am aware of. Yeah, gradual change.
Okay. Um, no, I think I don't have an answer to that now, but I will get back.
Surely, surely. I guess till now even I guess LLM is able to. I guess both would have similar semantic score only. Like if two sentences are put together in different ways, they will have similar semantic words. That is the only goal of cosine similarity, right?
Mhm.
Satyam, if you are in the chat, that is how semantic cosine similarity works, right? Rather than we are not doing TF-IDF or any index-based searching. There's completely on cosine similarity where you focus on the meaning of the sentence. I guess this solves the problem. Satyam, if you can confirm. Do you have any other questions left?
So, let take one.
Cool, cool, cool. Then I guess
We can proceed. Yeah.
cool. So today has been, yeah, okay, understood. Basically, a semantic thing comes from the only concept of meaning, what the sentence means, rather than what is in the sentence, right? So it doesn't matter how the words are put together. What is the meaning? That is the only thing which will come in the semantic search. That is how semantic search is better than TF-IDF. Cool. With this, we come to the conclusion of today's session. Today's
Mm,
session was, I guess, one of the longest session we had.
sorry, we have more, like it was just a part, and Soumendra is like V1. We have covered the halfway of V1, I guess.
Okay.
Mhm. You're
Okay.
just taking the question. Yep. Soumendra, you can let me add the screen. Yep. You can continue.
Yeah. How much time we have?
We can have around 12:45. We can stretch.
12:45. Okay, 25 minutes. Okay, it will be complete before that.
That's fine. Then let's proceed.
Okay, so this is how. Yeah, we are creating the summary. Um, yeah, batch wise summary we are doing here. Summarization chain we are giving batch and tables if anything is there. The table summary also it's doing, and text summaries you can see how it will appear. You can see this pointer. Where is it running now? Okay, so the first page summary it got that and decreasing cost and monetization of AI. So only in one sentence, which is within the 1094 token limit, it got a response like OpenAI had these things, and to summarize that, it has summarized like this. Then we have few images. So image summary we will do. So create image summary, encode image with image file. So this is just defining function, image summarize. Vertex AI, we are using another model here, Gemini 2.0 Flash, maximum output token second 1024, and human message we are using here, and image URL we are giving blah blah, and image summary we are doing, and list directory the path we have given. So in this path, whatever images are there, so it will iterate over each one and summarize. Message model executing. Oh, it executed. Okay, it shows the first one, line graph showing EV NTM revenue multiples Jan to October. So which one is this? EV NTM revenue. I think this is the first one. No, not this one. Yeah, this one. EV NTM revenue it was showing. Okay, let's go next to. So here we see that how one image also it got summarized like what exactly this image is telling. So this model is multimodal, so it can process the image also and find out the meaning what is inside it. Next is multi-vector retrieval, like create retrieved index summary that returns to what it does. Also, this only defined here. These are some utilities. Okay, defining whether image is data, resize, split. They execute this. Yeah. Okay, what is this? Join the context into single string. You are a financial analyst asking with providing investment advice. You will be given a mixed up text table images usually with chat graphs. Use this information to provide investment advice. Okay. So we are again giving prompts here like what to means placeholders, text image, messages dot append, and text image, context image. Okay, this question we have given here, formatted text. Acha, it's already here, text. Okay, so join the context into a single string. So all the image and the thing it's appending into a single string. So text message it's already there, and image message it has appended here. Okay, so define multimodal array chain. So multimodal array chain, lang chain is creating again same model, output token same, retriever, runnable lambda, split image text types. Okay, what it does I forgot. Then runnable pass through the question directly we can give, and runnable lambda model and processor. Then chain multimodal array got created using multimodal array chain this function with parameter as retriever multimodal image, which is this, which is given here as a context. Okay. Then so here we have asked a query: what are the EV, NTM, and NTM revenue growth of MongoDB, Cloudflare, and Datadog? These are three companies, and we asked like, give us the EV, NTM, and NTM revenue growth. So length of docs and total docs. Length of docs didn't give. Should I add it? Two. Okay. Two documents it got retrieved, and these are the documents value. Oh, so large, long documents. Then if we plot those, okay, two documents. So it should be into, okay. So we got two images. This one is first one. Yeah, I think this one has Datadog, Digital, MongoDB, and Cloudflare, but it doesn't have NTM and other thing. EVNTM, is it? No. And there is another one, first one. Yeah, this one has again Cloudflare Datadog and EVNTM data it has with the growth. Okay, now if we run it, and it will show the result now. Okay, based on the, so LLM is providing the result based on the provided table. Here is the information. So the query we asked, what is the EVNTM, NTM revenue growth of MongoDB, Cloudflare, and Datadog? And here we got for MongoDB 14.6s and growth. What was NTM revenue growth 17%, and let's say for Cloudflare 13.4 and 28%. Yeah, so it's coming correctly. So yeah, this is how we can ask both in text and image RAG. Yeah, you can try this yourself. Any questions?
I guess we don't have any questions from Indra. Folks, if you have any questions, you can drop them in the chat. I'll give a moment. Till now, we don't have
Yeah.
any questions. Okay.
I guess the best thing today about today's session that we actually gave some collab notebooks for people to go through the code. Thanks, Soumendra, for that.
Welcome.
Folks, if you have any other questions, feel free to drop in the chat. Otherwise, we can wrap up today's session. I guess there are no questions. So we are good to go for wrap. Thank you everyone for joining today's session. Uh, Team, if you can have my screen up, that would be very helpful. So,
Yep.
folks, thank you for joining in. I know today's session have been a little longer than our usual session, but I know that uh, it is the same. We as we go on deep into AI, the sessions sometimes get stretched. Thanks a lot, Mr. Soumendra Kumar Sahoo. Today's session was really one of the great session that we ever had till date. Guys, you can follow this QR to scan the link and follow Soumendra on LinkedIn. Thank, uh, thank you everyone for the wonderful comments and doubts, everything that you had. As we move on, feel free to have anything. If you have any other queries or any feedback for us, please feel free to follow. Put them on the chat. We will definitely take them into into consideration. Uh, we are Folks, one request, if you we would really feel great if you can just scan the above QR and fill up the feedback form. Means a lot for us. We can get various feedbacks and what all we can do much better, whether in terms of streaming or in terms of the content that we deliver or whatever you guys feel that we can make better from how we are doing today. With that, I guess today's session comes to an end. This today's session have been great. I guess we all can build successful, full-fledged RAG pipelines from now on. We have already shared notebooks. We will be also dropping mail on whatever have been delivered today. We will be also dropping those over the mail. If you have any comments or feedback, please fill up the feedback form. That's only one request. That us keeps us motivated also to make such content, make having keep sessions. I guess with that, today's sessions come to an end. Thank you everyone for joining in. Thanks once again for spending around 2.5 hours from your precious Sunday to joining in and supporting community development. Thank you everyone for joining in. That's all, I guess.
Once again, thank you everyone for joining in the Sunday morning till the Sunday afternoon. Thank you for all the valuable questions and all. Also, great. Thank you to all the community members, to the speaker, and to the whole team of TFUG Bhubaneswar. If you have any questions, feel free to drop them in the chat and follow us on our social media handles. And if you have not joined our community yet, feel free to join the community by scanning this QR code. We have plenty of more sessions, such sessions planned with Build It AI and other related to AI. So once again, thank you so much for your valuable time and with us in the Sunday afternoon and morning. Hope you had a great time with us today. Till then, see you and keep coding, keep curious and keep asking questions.